This is part 4 of section 5.6. We're doing long division. If I look at this one, I have a 4, 3, 2, 1 constant. Everything is there, everything is in order, the numerator is good. In the denominator, I have a y squared, I do not have a y, and then I have a constant. Anytime you're missing something, you're going to add 0 and then whatever term is missing, so 0y. Now, we dealt with the 0 in the previous problem, and when the 0 happens on the top, it doesn't ever really feel that weird as you're working the problem after you get the 0 in there. When you have a 0 on the bottom, it does feel pretty weird because you're going to be writing 0 a whole lot and you're going to want to just make it go away. You definitely want to keep it around for a while. Okay, so if I work this, I set it up 3y squared plus 0y plus 2 divided into 6y to the 4th plus 9y cubed plus 10y squared plus 6y plus 4. The process is just exactly the same as it has been. I want to make the 3y squared into a 6y to the 4th. So I'm going to need to multiply that by a 2y squared. Now take that 2y squared and distribute it through everything. So here I get 6y to the 4th, and this is what I mean where things start to feel weird. Because I'm multiplying this by 0, and we know that that's just a 0, and we want it to go away. We need this. This is a placeholder for us. By having this 0 in here, it keeps us from accidentally adding or subtracting terms that aren't alike. I'm going to take this and I'm going to multiply through here. Yes, it is a 0. But I'm going to write plus 0, and I'm just going to write y cubed. These line up. Y squared times y is y cubed. Just we're multiplying it by 0, so it goes away. But it does keep my terms lined up. 2y squared times 2 is going to be plus 4y squared. We are subtracting, so change every sign. Your first term should cancel out. And it does. So I have 9y cubed plus 6y squared. Bring down the plus 6y, and I suggest you go ahead and bring down the plus 4. And repeat. We want to match 3y squared to 9y cubed. So I should multiply that by a positive 3y. Take the 3y, distribute it through here. 9y cubed plus 0y squared. Again, I'm keeping the 0 around because it's a placeholder. Plus 6y. We are subtracting, so we change every sign. Our first term should cancel out, and it does. And now we get 6y squared. Now these two cancel out. I might not need a 0 here, but I might need a 0 here. So I'm going to keep plus 0y. Now I definitely would not need the 0 if it happened on the left, but since it's going to happen between two values, I want to keep it around. Now like I said, I might end up not needing it, but I might end up needing it, and I can always drop it at the end if I don't need it, okay? Let's repeat. I want the 3y squared to be 6y squared, so I need to multiply that by a 2. So plus 2, take the 2 and distribute it. I have 6y squared plus 0y plus 4. Now change every sign and add. Our first terms should cancel out. Here, now this is on the left-hand side, so I don't need it anymore. It turns out I did not need this. But then 4 minus 4 is 0. So again, this one has no remainder. Your answer is this whole thing up here. Okay, let's try y cubed plus 1 over y plus 1. Once we get into the next chapter, you're going to be able to see how to do this one very quickly. But for right now, we're doing long division, and I look at this and I have a third power and a constant. I'm missing 2 terms here in the top, and I need to fit them both back in. So inside here, I'm going to do plus 0y squared plus 0y. And in the bottom, I don't need anything. It goes from first power to constant. It is possible, as you've seen, to have things missing in the bottom, have things missing in the top. You can have multiple things missing, and you can have things missing in both the top and the bottom. It doesn't matter where those missing terms happen. You've just got to remember to put them back in. Okay, so when I set this up, I get y plus 1 divided into y cubed plus 0y squared plus 0y plus 1. And by the way, if you are finding that you are having some trouble keeping things lined up, that you're losing terms and everything, I strongly suggest trying to use some graph paper to do this. Graph paper not only helps you line things straight across, but you can line things up and down as well. And it can help you a whole lot if you need to practice spacing these things out or you're losing things. It can force you to be neater and avoid those kinds of mistakes. All right, so I want this y to become a y cubed. So I need to multiply it by a y squared. Distribute the y squared. You get y cubed plus y squared. Change your signs. Your first term should cancel. And now I get negative y squared, and I'm going to bring down everything else. And we repeat. I want the y to become negative y squared, so I need to multiply it by a negative y. Distribute the negative y. You get negative y squared minus y. Change your signs. Add. First term cancels, and we get y plus 1. I want my y to become a y. Now those are exactly the same, so I'm going to multiply it by a 1. Distribute the 1, you get y plus 1. Change your signs, and everything cancels out again, and you get a remainder of 0. So y squared minus y plus 1 is the answer to this division problem. Okay, one more little topic, and it's about the function notation. We've dealt with things like this for addition, subtraction, and multiplication. Here's the division version. If you see f over g of x, they want you to take your f of x and put it over your g of x. Now this is new. Your gx cannot equal 0, and that's because we're never allowed to divide by 0. So I'm not allowed to plug in an x value that would give me a 0 in the bottom. That's all this means. Okay? So let's do f of x is equal to 18x squared minus 24x, and our g of x is defined as 3x. This says I'm supposed to put f of x over g of x, so this is 18x squared minus 24x over 3x. Now, if I were teaching you live in a classroom, at this point I would say work ahead of me. Try to do this division problem yourself, see where you end up, and then I would give you a head start, and then I would silently work the problem in front of you. So if you want to try that, you can pause it right now, try to work this, and then I will come back and do it. So pause. Okay, we're back. So let's try this. What I hope that you recognized, but is quite possible, in fact, probably likely that you didn't, is that we're dividing by a monomial here. So this is the easier type of problem. This can be done using long division, but you don't want to. All we have to do here is 18x squared over 3x minus 24x over 3x, and then reduce. 3 goes into 18 6 times. This 1x cancels out one of those, so from the first fraction we get 6x. Here the x's cancel. 24 divided by 3 is 8. 6 minus 8 is your answer here. And that's the end of this chapter.